Let's pick up where we left off, folks. We'll look at the antenna coil real quick. We'll start with the primary side. Let me pull the schematic up here and I'll show you guys what we're going to focus on first, and then we'll check the secondary. Back to the schematic here just for a moment. Here's our little antenna symbol here, and you can see there's two sections to the coil here for the primary side. The first section being called out at 1 ohm of DC resistance, and the second appears to be 8 ohms. And you can see if you follow that through, it goes down to chassis ground. So we'll connect one lead back to that tan wire where I cut the antenna lead from. We'll hook 1 meter lead there, and we'll attach the other side to ground, and we'll look for about 9 ohms of DC resistance, plus or minus 20%. You can see we've got a couple caps in here, in particular C2 that connects the primary to the secondary. So should C2 be compromised in any way, that being shorted, and some DC resistance flowing between the two. Of course, the DC resistance may be higher or skewed, so we'll look for that and just be mindful of that as we move forward. Let me get this out of the way. We'll flip the chassis over here and make that quick measurement and see what we've got. Alright, let me get the meter hooked up. You guys recall when I was shooting the first video there, I had my little small antenna lead hooked up here, and it goes to the tan wire, so it looks like it was hooked up correct, and this appears to be the ground conductor itself. So going back to the schematic, this is our antenna lead here. I'll hook in there, and then the other side here I just want to get a good ground, so I'll just use the antenna coil can itself here. See what we read. So just north of 7 ohms. That's fairly close there to the 9 ohms. We'll go with that and document that for now, but I think we're going to be in good shape here for the primary side of the antenna coil. Later on I may do some inductance readings. If so, I'll share the results of that. Alright, let's go back to the schematic real quick and take a look at the secondary of the antenna coil. Alright, moving along here to the secondary of the antenna coil. What I'm going to do, the tubes are removed, but the little small lead that attached to the grid of the 6A8G tube, I'm actually going to connect there. And you can see it runs over and it attaches to the tuning condenser. So that'll be easy to identify. We'll hook up there, and you can see it loops back through the secondary of the antenna coil, and then goes to a secondary path, and then we'll flip the chassis over and take a look, and let's see if we can identify that 0.05 microfarad cap that resides between the primary and secondary, and we'll hook up at this point and read the DC resistance, and we'll look for 4 ohms plus another ohm for a total of 5 ohms, again plus or minus 20%. Here's that grid connection that I just mentioned, that I showed on the schematic, that would attach to the 6A8 tube. So we'll tie in here with one lead. I'm going to flip this over here, and we'll go back to the antenna coil, pick out that 0.05 microfarad cap, or do our best to, and see what we have between those 2 points. Okay, I've got my one lead hooked up over to the grid lead that I just spoke about. And then looking underneath the chassis here, and it may be hard to see, I'll try to do a little picture-in-picture and show you guys from a different angle, but here's that 0.05 microfarad cap. One side attaches to the chassis ground here, and the other side, if you follow it back here, goes right back over to this section, or this connection point on the antenna coil. So let's hook up here, flip the meter on, and see if we've got somewhere between 4 and 5 ohms. And we do. So at least it appears, preliminary checks, that the antenna coil is good. At least it's not open. We'll do some additional testing if necessary. I'll document the results here. Now let's move along over to the oscillator section itself which should be right here. Taking a look here at the oscillator section, I think I've got a good connection point that we can check all the windings here at two different connection points. You'll notice here the variable condenser for the oscillator section. One side goes to ground here, and the other section comes up and attaches to the coil here. Now, of course, you can see I could go all the way back up to pin number 5 on the oscillator, but that won't work because we're blocked by C4. So what I'm going to do is just attach one lead of my meter to the oscillator section of the tuning condenser, which is the rear section of the tuning condenser, and then identify where the 0.003 microfarad cap resides here, and test at this location here. So you can see if we follow that all the way through, we should have continuity all the way back to that point. And that's what I'm looking for now, just to make sure that we don't have an open oscillator coil. Now, looking at the DC resistance measurements, what's called out here, it looks like I should be somewhere around, what, 2, 3, 4, greater than 5 ohms. I'll just note what we actually read, record that, and if we have problems in the oscillator section, we'll come back, of course, and do a deeper dive. Okay, here's my oscillator section. We'll tie in there and see if that will stay on there while we make the measurement here. And I was poking around just a little while ago, so I've already identified that 0.003 microfarad cap. It resides right here, and it does match the schematic where it's coming off the oscillator tube. And it probably won't show up well, but the other section attaches to the oscillator coil right down here. So let's hook up down there. Make sure we don't have an open. And you guys can see we're just north of 9 ohms. So I'll add that to my documentation. So we're looping through all 4 sections of the oscillator coil, if I've done this correctly. Again, if I'm wrong, we'll come back and do some additional troubleshooting here. Alright, let's move along now to one of the IF coils, see if we can do some troubleshooting there as well. Back to this first IF filter here, T3. You can see the primary side here, that being the left side, called out at 25 ohms of DC resistance, while the secondary as well at 25 ohms. What we'll do here is focus on the primary side first, and you can see the top side of the coil goes back over and attaches to pin number 3 of the oscillator tube, the 6A8G. So we'll do one tie-in at pin number 3 underneath the chassis. Then if you follow the output, or the lower side here of the primary, you can follow this line and see that it comes across here, comes back up. This is our B plus, of course, and I've got a couple really nice tie-in points that we can check for 25 ohms, plus or minus a few ohms of resistance here. If you follow this down, I can go over to pin number 2 on the rectifier tube, the 5Y3. That'll be one location. And then if you go back to this location, follow this up, you can see it goes to the primary of that output transformer that we just tested. We'll go over to pin number 4 on the output tube. Both locations should read, close to the 25 ohms of DC resistance. So let's get hooked up here underneath and make those measurements and just confirm that the primary winding itself is not open. And then we'll go back over to the secondary side and look at those connection points and measure the DC resistance here as well. So that first location point was back on the oscillator tube here, pin number 3. Now you guys may not be able to see this on camera, but this particular tube socket, and I think some of the others, are marked. It makes it really nice and convenient that again, I can identify this by the keyed area here and counting in this direction here. So pin number 1, pin number 2, pin number 3. And that does match what's called out here on the socket itself. So we'll hook up here, flip the meter on, and then the next location, we'll just go straight down to the rectifier tube, and that's located here. And I'll look back at the schematic, and we said I want to go to pin number 2. This particular tube socket, you can probably see, is also marked, but again it's keyed, so it can go 1, 2, and that does match. So we should be able to look at DC resistance here, and you can see we're just shy of 24 ohms of DC resistance, so it looks like we're in good shape there. You can see this connects, right back up to the 6F6 tube. And we said we wanted to look at pin number 4 there. Let's just make certain that we have the same DC resistance there, or close to that. And this is pin number 4 here. So let me just hold that on there, see if I can get a good connection. And indeed, we have the same DC resistance there, just south of 24 ohms. So the primary of that first IF is, at least not open. Let's take a look at the secondary real quick. Again, the secondary of T3 being this right side here, you can see I've got a nice point of contact here, that being the grid of the 6K7 IF amp. So this will be one connection point here. Moving down to the bottom side of the coil here on the secondary side, you can see I'm going to have some options. We'll go left here, and you guys recall the 0.05 cap that we had there, number C2, that we were looking at when we were troubleshooting the antenna coil. I can use that point, and in addition I'll probably come across here and we'll move up, if I'm reading this correct, pin number 4 on the 6Q7G, that second detector AVC first audio. So let me get hooked up and let's check those 2 points and see if the secondary closely matches the called out DC resistance here of 25 ohms. Okay, here's the grid connection that I just referenced on the schematic itself. That again, this point would tie back in to the 6K7, the grid tube. So this area we already talked about is kind of suspect, so we'll take that tape off during the restoration and see what's going on there. But let's check the DC resistance now. You guys noticed I color-coded the tubes here, and the reason why, I'm going to invert this in just a moment, and it just helps me identify the tube locations underneath. Sometimes it's confusing looking at it from this direction versus the opposite direction. So I've showed this trick before. All I do is just flip this over and use a bright light, and I'll show you guys here in the picture-in-picture. Just a little shortcut you can use kind comes in handy once in a while if you don't want to go to the trouble flipping the chassis back over, especially if you've got a chassis that's extremely crowded with a lot of tubes. And of course I've done that same for hand drawings as well. Works out really well. So I'm hooked up at this point here with my red lead, and then we'll just go ahead and throw the black lead here off the multimeter back here on the 6Q7 pin number 4 that we talked about, and that resides right here. Now this tube is also keyed, so I can count here, 1, 2, 3, pin number 4. Let me see if I can get this resistor out of the way. And indeed, that's called out as pin number 4. We'll flip on the meter, and again we're looking for 25 ohms. And that's not a good sign. You can see there we're about 5 meg. Okay, our other point that we said we could test off of, let's see if we get the same results. So we were here, we came down, I went to pin number 4 on the 6Q7. Let's go back over to that 0.05 microfarad cap that we were looking at earlier that's in the antenna coil circuit, to be easy to identify. And let's see what we get there. Here's the capacitor. This side is the ground lead. This goes over to the band switch. And we're reading right at our 25 ohms, or 24.9 as called out on the schematic. So let's go back to pin number 4. Still 5 meg. So something's wired different than the schematic. Let's take a closer look at the schematic here and see if we can figure this out. I think I know what it is because I've run into this many a times. Alright, the 6Q7 tube, that being the detector tube in AVC, you can see we've got 2 plates, pins number 4 and 5. So there's your little plate symbol. I'm guessing when this thing got wired, this thing is just switched. So pin number 4 is probably location number 5, and then we'll probably find the same, that the T4, or the second IF filter, the secondary, is probably tied to pin number 4. Let's just do a visual on that real quick, and then we'll check the DC resistance on pin 5 and see if they're just inverted. Just a visual here, I can tell it is. Let me see if we can get down in here where you guys can see it. So here's pin number 4, and you'll see this lead coming out right here, and it's going back down through the chassis. And this is actually our secondary transformer T4. This is pin number 5. We'll see if we have 25 ohms at this location. So no big deal, but it's something just to keep in mind if you're working on one of the vintage radios. You may see some differences in cases where you have 2 plates on a tube that could be interchanged. So let's see what we have here. So that's a good sign. We've got our 24, 25 ohms of DC resistance. So I'll just note that on the schematic for future reference. And each build could be different. So I may have another radio just like this, and it will match the schematic perfect. And I reckon it's just the way the craftsperson that was building or assembling a radio wired it together. So no big deal. So just looking at the DC resistance there, we should be fine on that first IF filter, at least from a DC resistance check. Let's move over to T4, or the second IF. And while we're focused on this tube, and we already know that this is inverted. We'll go ahead and check the secondary first. Let me get the schematic back up here. Okay, what we'll do real quick here, here's the secondary of the second IF T4. We'll go back to pin number 4, not number 5 is called out here due to that issue we saw where the wires are crossed. And let me see if I can identify R4, R5, or C10 underneath the chassis, and we'll attach at this connection point and see if we can match our DC resistance of 25 ohms. You guys can probably see this, but here's your secondary windings. This chassis is so wide open it makes it easy to identify, and you can see these are keyed where you've got your primary and your secondaries routed separate. Unlike a lot that come out all together and color coding's wore down, you can't really tell what's what without doing a lot of true measurements. So what we can do here is just go back to pin number 4 again, which is inverted with pin number 5, no big deal. And then this other lead right here attaches back over to appears to be pin number 6 here. So we go back and read this. You can see we have our 25 ohms there. So we should be in good shape here.